Exercise A01 is there just to solidify, to strengthen your understanding of what is true and what is false in the C language. And this is somewhat of a picky topic, a difficult topic, because as you will have many opportunity to realize, the C language is trying to interpret almost anything down to a true value if you ask it to do so. So you can write a if statement, and inside of your condition have things like calls to function, even a printf statement, etc. And you will see progressively through those exercises how the C language is going to try to make sense of those values in terms of true and false. And the rule, as was explained in the textbook and the lecture, is pretty much that 0 means false, and anything else than 0 means true. So this little exercise is going to submit for you to consider a couple of expressions. Okay, and for each of those expressions, this is a job you have to do. You have to printf the result of evaluating each of those expressions as an integer to see how the C language represents them, and then you have to printf whether the expression is true or false. And what I suggested you do in the exercise is to use here a printf %s and then a ternary conditional operator. So let's open our Conqueror. Let's open our kwrite on a fresh program A01.c. I already took care of the border code work. And now we are going to simply work on each of those expressions as indicated in the exercise. And I will comment when things are leading to weird results. So I'm popping back up here the text of my exercise, cut and paste, go back to my code. I'm putting this in a comment, okay, so that there will be no syntax error triggered by this expression. And I'm going to cut and paste them as I build the printf statement going with them. So what kind of printf statement do I need? Refer back to the exercise once again. This is the first one. This is the second one. And I'm going to have to do those two printf for each expression. Okay, little problem here, there we go. So what I'm going to do, and you can do it like different ways, of course, but what I'm going to do is I'm going to display on the screen something that is relatively readable. Okay, so I'm going to say, for example, expression, and I'm going to put here my expression, A lesser than B. This is the first expression I'm trying to evaluate. Okay, I'm going to put a tabulation, and then I'm going to display its value, and I'm going to display the value followed by whether it's true or false. And I'm going to separate all this by tabulation. So I don't use a \n, okay? But here I will display value equal %d, another tabulation, okay? My expression here, and I'm going to start using this cut and paste mention. My expression here will be this one, conditional expression. So this conditional expression is going to evaluate into something, and I'm going to display this value as a %d, that is as an integer. And then here I'm going to do the same, I'm going to use the same expression, of course, but this time I'm going to test with a ternary conditional operator whether it's true or false, and display accordingly whether it's true or false right here. And then I go to the next line. Okay, before to go any further, so I took care of expression number 1 here. I'm going to remove it from my commented to-do list. I'm going to save this file. And before to go any further, well, I'm going to have to fix this, but before to go any further, we're going to make sure it compiles. So there is a problem with the cut and paste I did that introduced Unicode characters. So, okay, let's see if I can solve this by just removing it. Okay, I'm going to have to do a little bit of maintenance here. I'm going to pause the video, fix the Unicode setting in the file, and be right back. Okay, there we go, we are back. I had to just make sure I resave this file appropriately, so I had to modify it pretty much restarted because I made this cut and paste from Windows application, so I didn't think this was worth putting on the video. So we are going to move on now. We have exactly the same code. Okay, I didn't change the semantic of the code, of course. We are going to display the value, then we are going to display the true value as a string, true or false. Okay, let's move on to Conqueror. We have something we can test, so let's test without moving any further. GCC A01, let's see, compiles okay. A.out executes. Expression A lesser than B, character A lesser than character B, value is 1. Truth value is true. Well, if the value is a decimal value is 1, yeah, that represents true. Remember, everything 0 is false, everything else is true. Now, what does that mean to do A lesser than B? Well, a character is encoded as its index in the ASCII table in C language. So we're talking about character A, which is, let's say, index 61. And we're comparing the value of character A, which is 61, with the value of character B, which is 62. Is 61 lesser than 62? Yes. Therefore, the expression value is 1. True. Okay, so that shows you that even data types that have nothing to do with Boolean, like if you come from Java, for example, you're used to Booleans, well, data types that have nothing to do with Booleans can be compared, etc., as long as they are ordered. And a ASCII table provides order on the set of characters. So this is it. We have here our first example of using comparison between two arbitrary data types, resulting in a Boolean value true false. It's not that exotic because we are still comparing values here. Now we could, as we are going to do with overvalue, try to extract a true value from things that have nothing at all to do with Boolean. Our second expression, A less greater than B, I'm going to let you experiment with it. Okay, very easily. You can see that if you take a cut and paste here, there we go, you can see that this is going to be absolutely no problem to understand. The only thing you are going to discover with this is how you represent the value false. And the value false, you already know that, is represented by 0. So we'll do it real quick, okay? Just get you started on the couple of first values. I'm creating my second expression here, save it, go to Conqueror, GCC. Execute. There we go. Value 0, true value false. Okay, what's next? Well, the next one is going to be 0, 1, minus 1, etc. So 0, 1, minus 1. Let's go and try to do some quick cut and paste to generate this code. 0, 1, there we go. This one is going to be expression just 0. Okay, and this one is easy to predict, just as the next one. I could simplify here the notation for this expression, but I'm trying to go with something generic. So I'm going to do 0 here, and I'm going to cut and paste it. This is going to be for 1, and this is going to be for minus 1. So this is kind of the canonical set of value, okay? Just to make sure you understand and you can like prove to yourself with a little program that 0 is false and everything else, including minus 1, including negative number, is actually true. This is a very common error from beginning C programmer to assume that if it's negative, that means no. No, that has nothing to do with that. Okay? The only order rule is 0 is false, anything else is true. And you can see here, 0 leads to false, 1 leads to true, minus 1 leads to true as well. So we are just getting rid here of common misconception. The next one, negation of 0, negation of 30, negation of character C. Let's go ahead. I'm going to take this one, for example. Negation of 0, negation of 30, I think. Negation of character C. Expression, negation of 0. Let's go. Negation of 0 here. Same thing here, negation of 0. Negation of 0, then what? Negation of 30 and negation of C. Okay. Negation of 30. So negation of 30, 30 is true. So that's going to be representing false on the screen, okay? However, the interesting tidbit here is how do you represent false? Do you represent it, well, actually no, let me like remind on this. Representing false is easy enough. It's representing true that calls for a specific convention, because remember, false is only 0. So every time we have to represent false, it's easy enough, we use 0. Every time we want to represent true, well, theoretically, we have a choice. The C language could use any value that is different than 0. Well, let's have a look here. Let's save this. Go to Conqueror, compile and run to see how it's actually representing it, what value it uses. A.out, and there we go, we're done. So, not 0. 0 is false. Not 0 is true. This compiler always chooses to represent true by 1. True value is true. Not 30. 30 is different than 0, so it's true. Not 30, the value will be 0, which means false. C, same thing. The character C has an ASCII code. Let's say, for example, 63. Okay, 63 is true. Negation of true is false, represented by 0, interpreted as false. And I'm going to put the program back on the screen. It was a very easy program to write, and this illustrates a bunch of common mistake, common misunderstanding as to what the C language does to interpret, Boolean expression.